Welcome to NovaStar course. This video will introduce you how to adjust performance settings and use receiving card configuration files with Nova LCT. In the previous videos, we have learned smart settings and cabinet settings to make a cabinet work properly. But how to make LED display performance parameters such as refresh rate and grayscale meet requirements? This is where performance settings comes in, and the proper use of receiving card configuration files can save us a lot of work. The purpose of performance settings is to allow an LED display to present optimal visual performance while maintaining stable working condition. A receiving card configuration file is a file that saves receiving card configuration parameters. The file format is RCFG or RCFGX, so it is also called an RCFG file. How to adjust the performance settings? Open Nova LCT. Choose User and Advanced Synchronous System User Login. Enter the default password admin. Click Login. Click Screen Configuration. Make sure the current communication port is selected and click Next. Select the Receiving Card tab. Parameters displayed in the Performance Settings area vary according to the driver chip of the module. This video will use Common chip and PWM chip MBI 5252 as examples for demonstration. For Common chip, shift clock frequency has influence on refresh rate, loading capacity, and grayscale. Adjust these parameters according to the following steps. 1. Make sure the module and cabinet information are correct. 2. Select a grayscale mode according to the application scenario of the LED display. Brightness first. For outdoor LED displays, high brightness is required. Refreshing rate first. For indoor LED displays, high refresh rate is required. Grayscale first. For rental or stage LED displays, high grayscale is required. Performance balancing. The LED display is used for applications which requires a balance between brightness, refresh rate, and grayscale. 3. Adjust refresh rate times to the maximum, which usually is 8, 16, or 32. 4. Adjust refresh rate to the value required by the customer, which usually is 1920 or 3840. 5. Adjust grayscale level to the value required by the customer. For example, normal 16384 refers to a 14-bit grayscale, and normal 32768 refers to a 15-bit grayscale. 6. If the cabinet resolution exceeds the loading capacity of the receiving card, increase shift clock frequency or decrease refresh rate and grayscale level. After the loading capacity is increased by increasing shift clock frequency, click Send to Receiving Card. Select all receiving cards and click Send. Then, check whether the display is normal. If the display is abnormal, it indicates that the shift clock frequency has exceeds the limit of the module. Decrease shift clock frequency or decrease refresh rate and grayscale level. Keep trying until the display of the cabinet is normal. Please note: 1. As long as loading capacity, refresh rate, and grayscale are in balance, the lower the shift clock frequency, the better the display stability will be. 2. The performance parameters value of different cabinets may vary. Parameters values shown in this video are only for demonstration purpose. 7. When the display is normal and stable, click Save. Other parameters such as row blanking time, ghost control ending time, and line changing time are used to fix screen ghosting. Phase precision is used to fix mismatching and flashing pixels. Low grayscale compensation is used for fixed problems that some driver chips with narrow pulse width cannot respond correctly. Parameters for PWM chip displayed in the performance settings area are different. T-clock frequency has influence on loading capacity. G-clock frequency affects refresh rate and grayscale level. Here, we will use MBI 5252 as an example to show the adjustment. 1. Adjust T-clock to make the loading capacity of receiving card slightly larger than the cabinet resolution. 2. Adjust refresh rate times to the maximum, which usually is 8 or 16. 3. Adjust G-clock to make refresh rate and grayscale meet customer requirements. Click Send to Receiving Card, select All Receiving Cards, and click Send. Check whether the display is normal. If the display is abnormal, it indicates that the G-clock value has exceeded the limit of the module. Decrease the G-clock value to sacrifice refresh rate and grayscale. Send to receiving cards. Keep trying until the display is normal. 4. When the display is normal and stable, click Save. Other parameters such as row blanking time, ghost control ending time, and line changing time are used to fix screen ghosting. D-clock phase and G-clock phase are used to fix mismatching and flashing pixels. Please note: 1. Shift clock frequencies and G-clock frequencies greater than 20.8 are not recommended. 2. Performance parameters need to be adjusted several times until the display is normal and stable. How to use RCFG files. Receiving card configuration file. 1. Click Save to File to save the current parameter settings and create a new RCFG file. 2. Click Load from File to load the data in an RCFG file into Nova LCT. Then click Send to Receiving Card to apply the data to the entire screen. Three. Click Read from Receiving Card to read back parameters from a receiving card to Nova LCT. For example, the first receiving card is connected to the first Ethernet port of the first sending card. 4. Click Save to save parameters to receiving cards. This can avoid data loss after the screen is powered off. Now the performance settings and receiving card configuration files are completed. Thank you for your watching.